Welcome. This is the video for lesson 5.2. We're going to be learning about the trigonometric functions using the unit circle. And some things we're also going to learn in this lesson are the trig functions using the unit circle, relationships between the trig functions, how to find some exact values of special angles. We're also going to learn about reference angles, applying the Pythagorean identities, and applying the negative angle identities. So the unit circle says that we have a radius of 1. Okay, and so this point right here is 1, 0. This point right here is 0, 1. This point right here is a negative 1, 0. And this point right here is 0, a negative 1. And they are defining cosine of t as x and sine of t as y on the unit circle. That's our definition. And so if that's the case, it says find the sine and cosine of t equals pi over 2. Well, we know that pi over 2 times 180 over pi is equal to 90 degrees. So that is right here. So this is at pi over 2. This is the coordinate point. So we're talking about the point 0, 1. So that means that cosine of pi over 2 is 0, and sine at pi over 2 is a positive 1. Now, we're going to learn how to define the other 4 trig functions. Tangent is going to be the ratio of sine over cosine. Secant is, so let's do tangent is sine over cosine, and then cotangent is the reciprocal. It's cosine over sine. Then we have secant is 1 over cosine, and cosecant is 1 over sine. And one way we can remember these is that we have TOA, that's how I learned it. Sine is the opposite over the hypotenuse. And we're gonna put that together in the next lesson. And cosine is equal to the adjacent side over the hypotenuse. And this is all of a right triangle. And then TOA is for tangent. And that's the opposite over the adjacent. So calculate the exact value of secant at pi if defined. So secant at pi is the same as 1 over cosine at pi. And that is cosine at pi is a negative 1. And so this comes out to be a negative 1. Remember that pi is 180. Okay. We also have the reciprocal identities. Sine is the reciprocal of 1 over cosecant, or is the 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. And then we have the reciprocals down below. So it's just getting familiar with those and using them. Then it says find the exact value of cosine at pi over 3 and sine at pi over 3. Okay. Pi over 3, if we multiply by 180 over pi, we get 60 degrees. So we are going to find the exact values of pi over 60 degrees. So if we think of the unit circle, these are length 1, and this is the point 1, 0, and this is the point 0, 1. And if we do this is 1 here, and then this will be 1 up here. And this is the point 0, 1. So 1 and 1 pi over 3 is at 60 degrees. So 60 is 2/3 of the way to 90. So it's really this angle here. So they want to know what is cosine there and what is sine there. So we have to find those values there. To complete this, I want to show you refresh some things about geometry. If we have a right angle, which we're going to have, which is a right angle here, because we always take our angle straight out to the unit circle and then bring it down to the x-axis. And so that means this is our 60-degree angle here. So this is 60, and that means this is 90, and then this is 30. So that special triangle says that whatever your hypotenuse is, we're going to call that 2x. Then your 60-degree, your 30-degree is x. So we're going to base it off of that. So your 30-degree angle is x. Then your hypotenuse is double that. And then your side opposite your 60-degree angle is x times the square root of 3. Okay. And using the equation for a circle, we have x squared plus y squared equals 1 with this our radius. So we're at 0, 0, no shifting, and our radius is 1. That's our unit circle. And so I know that cosine is the cosine of 60 is my x value. And then my sine of 60 is my y value. So my cosine is just x. That's going to be x squared. And then my sine is going to be the x times the square root of 3 squared. And that's going to equal 1. And so we have x squared plus the square root of 9, or 3 squared equals 1. So we have 4x squared equals 1. So we have x squared equals 1/4. So x equals the square root of 1/4, which is 1/2. And so cosine is x. So cosine at pi over 3 is 1/2. And sine of pi over 3 is the square root of 3 times x, which is 1/2 times the square root of 3, or the square root of 3 over 2. That's going to be a special angle there. Now, all of these are actually at the end of this lesson, which I recommend that you print out and put out for yourself, make available because you're going to be using these. You can see at 60-degree, sine is 1/2, and cosine is 1/2, and sine is square root of 3 over 2. That is cosine, and that is sine. Think of it as alphabetically, C comes before S, so it's always cosine on the left and sine on the right. Okay. Sines and cosines of special angles and other quadrants. So it says for an angle T in standard position whose terminal side lies in one of the 4 quadrants, the reference angle for T is the acute angle that the terminal side of T makes with the x-axis. So like I said, it's always going down and referring, either going down to the x-axis or up to the x-axis if it's in the 3rd and the 4th quadrant. So let's practice finding a reference angle. So it says find the reference angle for T equals 5 pi over 6. So 5 pi over 6 is not quite 1 pi, so it is all the way over here. But then we bring it down. And so that angle is the reference angle that goes with this. And so we're looking at just pi over 6 as our reference angle. Okay. So our reference angle is right there. This is our reference angle. For example, 5 says, find sine of a negative pi over 3 for negative 4 pi over 3 and cosine of negative 4 pi over 3. So first we're going to, it's negative, and so we're going in the opposite direction. We're going clockwise, and we're going a full pi, and then into this quadrant here. So a negative 4 pi over 3 is a negative 1 pi, and then a negative and another pi over 3, another third. So we're going a third this way. So we're into this quadrant, so pi over 3 is our reference angle there. Okay, and so we're talking about what is sine and cosine in that quadrant. So it's always cosine and sine, right? And cosine in the 3rd quadrant is negative and sine is positive. Okay, so we are going to go, and it's pi over 3 is our reference. And we looked at pi over 3 in our circle. I was just trying to decide. I wanted to show it to you. So pi over 3 means we have a pi over 3. So it's going to be the same here, but it's this 2 pi over 3. It's in this quadrant. So sine of a negative 4 pi over 3 is going to be the square root of 3 over 2. And cosine of a negative 4 pi over 3 is going to be negative 1/2. This next page just kind of gives a unit circle just in radians. And then also tells you, and this little graph tells you where sine and cosine are positive and negative in each of the quadrants. So that's going to be a helpful one too. Letter F, example 5 says, use a calculator to approximate each of the following to 3 decimal places. And you're definitely going to want to go to a Desmos scientific calculator. So I would pull up my scientific calculator here. And then you can just go and click on sine and make sure that if you're in degrees or radians. So right now it's in degrees, but I want to put it in radians. So I'm going to put in a negative 1.3. And that is, answer is a negative 0.963. So a negative 0.964 rounded to 3 decimals. And then the other one is tangent. So tangent of pi over 2 is undefined. And so 5 pi over 2 is at 2.5 pi. Which means it would be tangent at 90 degrees, right? Pi over 2. And tangent, here, I'm going to show you my paper now. So tangent at 2.5 pi is 1 full circle and a half, and the half of a pi would be at 90 degrees or pi over 2. And tangent is the opposite over adjacent. So tangent is sine over cosine. So sine at pi over 2 over cosine at pi over 2. Sine at pi over 2 is 1, but cosine at pi over 2 is 0. So that's why it's undefined. And it will tell you that on the scientific calculator, but I wanted to show you why. The part G is using the Pythagorean theorem, the Pythagorean identities. So the first one that we're going to use that we've already used is x squared plus y squared equals 1. And that's just the idea of the unit circle. So the equation of a unit circle. But if we use the Pythagorean identity that says that we can put in cosine t of x and sine t of y. And so we get cosine squared plus sine squared equals 1. So this is going to be an identity that we're going to use. And then using reciprocal values, we can also come up with 2 other identities. One of them is that 1 plus tangent squared equals secant squared. And the other one is 1 plus cotangent squared equals cosecant squared. And so these are going to be important to have by your side and know how to use them. So example 6 says, given that cosine t equals 1/3 and that the terminal side of t lies in quadrant 3, find sine of t. Okay. Oops. So cosine t is 1/3 and that the terminal side lies in quadrant 3, so it's in here. So cosine is, remember I said SOHCAHTOA, cosine is adjacent over hypotenuse. So in this case, it's 1/3. But we have to remember that cosine is negative in the third quadrant, and so is sine. So it's a -1, and then the hypotenuse is it's going to be an this is going to be the 3 because it's negative. So it says cosine is equal to 1/3, and the terminal side lies in quadrant 3. So cosine should be a negative there. I had a typo. It's cotangent of t is a positive 1/3, and cotangent is sine is a cosine. Let me rewrite this. Cotangent is adjacent over opposite. And it's positive in the third quadrant because sine and cosine are both negative. So it's equal to 1/3. So my adjacent is the -1 and my opposite is the -3. Okay, so that's my cotangent. And we want to find sine of t. So sine of t is opposite over hypotenuse. And right now we know the opposite is a -3, but we don't know the hypotenuse. So we have to use our Pythagorean theorem that says a squared plus b squared equals c squared. And right now I know a -1 plus a -3 squared equals c squared. So I have 1 plus 9 equals c squared. The c squared equals 10. So that means the square root of 10 is equal to c. So this is my sign, but we never leave a square root in the denominator. I have to rationalize that by multiplying by the square root of 10 over the square root of 10. So the sine t here is a -3 square root of 10 over 10. Make sure you're always giving me a rationalized denominator and not a decimal answer. Leave it in radical form. And then we have our negative angle identities. So if we're taking the sine of a negative t, then that's equal to a negative of the sine of t. And cosine of a negative t is equal to a positive cosine of t. And so they're each different. So we want to find the exact value of sine of a negative 5π/4, which means it's just the negative of sine of 5π/4. And we can go to our unit circle at 5π/4, which is in the third quadrant right here. And I'm taking the opposite of sine. So it said to take the negative of that. So I'm taking the opposite of a negative square root of 2/2. So then my answer is a positive square root of 2/2. And J talks about repetitive behavior of sine, cosine, and tangent. And it says let t be a real number and let n be an integer, then we know that we are just taking multiples of sine. It's just going to be sine of t, and multiples of cosine is going to be sine of t. So we're just circling back around. So whenever you're doing multiples, like coterminal angles, and then repetitive behavior, tangent. And tangent is not on the 2 pi cycle, it's on the pi cycle. So it says determine the exact value of sine of 11 pi over 4. So sine of 11 pi over 4 is, I can break that into 4 pi over 4 plus 4 pi over 4. That's 8 pi over 4. So then we have another 3 pi over 4. If we get to add them together, our numerators or denominators stay the same when we have 4, 4, 8, 9, 10, 11 pi. So this is 2 pi here, right? So sine of 3 pi over 4 plus 2 pi is the same of just sine of 3 pi over 4, because we can cancel out the 2 pi because these are coterminal angles. So sine of 3 pi over 4, we're going to go to sine of 3 pi over 4. It's in the second quadrant, and the sine is a square root of 2 over 2. It's positive in the second quadrant. So get familiar with your unit circle and the values in radians and the values in degrees, because the more you get familiar with this, the more you'll feel confident and you can just work and think about other parts of the problem rather than trying to find everything on the unit circle. It's going to be helpful to you. Catch me back for the next lesson video.